So good morning again. This is David Mallet from Larson Software. Just like to welcome you to the first webinar of 2021. Today's topic is 3D file formats. This is in our kind of talking technical illustration session, so it's a bit different to what we usually do. It's kind of more informational about what we're doing or what our strategy is. Than purely about products. So hopefully you enjoyed today's session. It will be recorded, so you can pass it on to colleagues if you want to. So let's get started. Oh, by the way, Don Larson is also joining us today. He's going to stay in the background, monitor any questions that you might want to ask. We will. You can interrupt us. You can raise your hand if you want to talk, or just ask the question through the questions panel, and we can answer those as we go along, or we can answer them at the end. But if you have something you want to say, if you want to ask a question, just raise that hand, and Don is going to monitor that, and we can always open up the mic for you to ask the question. There's also some associated materials for today's session in the handouts, and you can drag and drop those at any time, download them. And as I said, you can post questions or comments during the webinar into the panel. So we encourage you to do that. We want it to be interactive. We certainly don't know everything about 3D, so we also like to learn from other people. So these are our kind of comments and strategies moving forward. So if you're not familiar with Larson, we're based in Houston, Texas. We moved into that location last year. It was founded in 1984, over 30 years ago. So we've been in the software business a long time. We develop graphics software and toolkits. So we develop off-the-shelf software, but also software development kits for a lot of the formats we support. We've been really promoting the use of CGM for those 30 years. And at one point we had a free viewer, which we now have in our store, which is available for a small subscription. We also developed the first and only, to our knowledge, HTML5 CGM viewer, where no plugin is required, with a member of the CGM Open Foundation, and really well known for our graphic software in tech pubs, also in manufacturing and geology, in the oil and gas industry. And you can find us at those websites. So today's agenda, we're really going to talk about 3D. We've been working quite heavily with 3D over the past couple of years, trying to define a strategy for it. We think it's something that's going to grow in technical publications in the next couple of years. Not as much kind of processing files to go to 2D illustrations, although we have a solution for that, but more kind of publishing 3D in technical publications. So we wanted to try and define a strategy around that. So we're just introducing the 3D file formats, data exchange formats, CAD native, publishing, what we call publishing formats, which we'll explain later. We'll kind of detail those formats. Also, certainly the publishing formats especially, and also we'll a small announcement about support of a new 3D file format. If we actually needed another, but in our case we did. And then the last part, publishing 3D data, that will be mainly a demo. So just a relief from all slides, and obviously that will be live, as it usually is. So some of the terminology we're going to use today. So obviously 3D file formats. Main two we'll talk about is for data exchange is STEP and IGES. We'll also be talking about publishing formats like X3D, GLTF, and VRML. So don't worry if you don't capture the slides now or capture this information now. Don't worry, we'll be making these slides available through LinkedIn, through the event website on LinkedIn. So as an overview, I think they can be really categorized at the top level as open and native formats for 3D. So when I mean open, I mean they're not owned and they're non-proprietary. So they're usually governed by a non-profit organization, and so easily available, reliable, but also you can kind of standardize on them because they're open. They should be interoperable between systems. And then we have native formats that are owned, that are proprietary, which do not usually interchange between different, for instance, CAD systems. Although in some cases the software company does publish those native formats, usually at a cost to somebody, so they can support them in their perhaps data exchange software. And we usually would categorize 3D files into kind of two camps, data exchange and publishing formats. So the open formats for data exchange, STEP and IGES, certainly very good for data exchange tasks and readily available from all major CAD systems. So we'd probably advise that if you bring in data out of a CAD system, if it's not possible to use native, then STEP definitely would be the one we would choose. It's the richest format and very reliable and robust. From a publishing point of view, if we want to publish this information to technical publications, technical documentation, then there's a large number of formats available that would seem to be mostly open, but there are proprietary ones as well, mainly associated with a particular piece of software and viewer. So 3D data exchange. So the major two open CAD data exchange formats are STEP and IGES. STEP being the newer one, IGES has been around for quite a while. They're data rich, so you really get some good results from these files, although they can be large files, which is obviously a downside if you're processing them. The other file format, which I didn't mention earlier, is JT, another open format, mainly used in PLM systems, product life cycle management. But it's also probably a good interchange format. It's a lighter format than STEP and IGES, but you just need to be careful. If it's lighter, then there's obviously some things that might not be there that you will need or might need. The other option for data exchange is the native formats, but that's only really if they're supported in the target software where you go in. So I think I've always be wary of native formats. Certainly, if you're publishing those out for people to view, then you're going to be using like a proprietary viewer. So possibly not the way to go. We have a couple of polls, not too many. So the first one is just to see if the audience use any of these formats. So I'm going to just launch this now and give you a few minutes to respond. And the poll should be open. Please vote. This is totally anonymous. There's nobody logging this information other than the percentages. So hopefully you're kind of using some of these formats, and I'll give everybody just an opportunity to vote. You don't have to. It's not. It is optional, and perhaps you don't even use any of the formats. So I'll give you a couple more seconds. Okay, I'll close it at this point, and then I'm going to share it. Okay, so quite a few of you used STEP already. Smaller percentage IGES, JT, and 50% other. So there's formats we're not really accounted for there. Unfortunately, with the polls, I can't allow you to kind of comment and enter what those formats might be. So, um, but that's interesting that STEP is obviously predominantly used, but also that 50% are using something else. So that's interesting. So I'm going to hide that. Okay. So thank you for your input there. That's useful. So native formats, really the major CAD systems obviously have their own formats like CATIA, Creo, SolidWorks, uh, and you could use the CAD system itself to repurpose the data for technical publications. Certainly that's done by saving in various formats. But it might not be the best choice to get the best quality. And certainly downstream, you would still probably need to do something with the file, like adding hotspots or changing the format to something compliant with your system. So perhaps that's not the best way to go, but it could work for you, depending on your downstream, what you're actually publishing. So there's certainly in the publishing world, if you wanted to publish these files, 3D files out to go into a web browser, there's a multitude of formats to choose from. There are some proprietary ones. I'm not going to mention them specifically by name, but there are proprietary ones out there, but there's certainly a lot more open formats. So some considerations when selecting a 3D format is certainly want that to be easy to implement in viewing the model, preferably in probably a web browser. The file size is obviously important because the bigger the file size, the longer it would take to render that on the screen. And also in the technical publications arena, it's important that you can add that metadata, say interactivity and hotspots, and probably the ability to link those hotspots to external text. And also the support of how you display that text as well. Something called placarding is where the text actually remains, it doesn't rotate with the model, it actually stays flat. And that could be something important for legibility and instructions. So if I've not explained that very well, we'll probably have an example of that later on in the demo. So a bit more detail about those formats. Certainly CAD has become a very important source of information for technical publications, certainly in the illustration arena. And as we've seen there in the poll, STEP is probably the most common one used, as most CAD systems support it, but also saving it as a part of their process as well. Because it contains a lot more information about the model than just kind of the surfaces or whatever. It contains a lot of other information, which is very important. And it is also interoperable between CAD systems. So if a company has more than one CAD system, it can use it as a way of exchanging data within engineering departments. The main consideration is a large file size. So actually kind of handling that, you need a decent sized computer memory and a processor. And I would say it's not really suitable for publishing. So you need to take it into some other format to do that. I just probably moved back into is now in the background a bit because really STEP has taken over. So the one thing I found is that the STEP is probably better than supporting solid models, whereas IGES is better at surface models. So again, you might need to consider that with the type of data that you're actually exchanging. You know, what kind of data is it? Is it like a panel, or is it something mechanical? The final one is JT, which again has been around for some time. I said it's a lighter weight format. Um, developed by a company called Engineering Animation, and then pioneered by Unigraphics as their kind of open format for transferring information. So it is lightweight. It's a smaller file than STEP or IGES. In the publishing area, there's certainly, as I said earlier, many formats to choose from. The ones that we've been focusing on as a company are X3D, which is based on XML, which is kind of an ideal kind of scenario for some of the businesses that we work with in aerospace and defense, for example. The only kind of caveat for X3D is that it can be quite a hefty file as well, like create large file sizes. Kind of an older format, which kind of X3D came from, was VRML, and certainly that's widely used for viewing models on the web and so forth. But it's kind of wearing a bit now. It's an older format, and certainly we've kind of been looking at GLTF as a better kind of alternative. Again, a light file, but really geared up for the web, and very quick, and it can add a lot of the things that we need in technical illustration, like hotspots and so forth. So that's looking like a good candidate going forward for publishing illustrations on the web. Yeah, really rendering quickly and all the interactivity that we might need. The other one, which I haven't mentioned so far, is 3D PDF, and I know a lot of people use this as a format, and we'll discuss that in a more. I've got an example file and so forth, so you can see what it's about if you're not familiar with it. Obviously, PDF is pervasive, so it's got to be an interesting format. So a bit more detail, as I mentioned, X3D is from XML. It has the ability, the good thing it has the ability to have a specific profile, which means it could have a schema, which means it could be validated. So in aerospace and defense, that's quite a crucial thing to be able to do to kind of standardize the file. However, say for instance, S1000D, although it's given a lot of guidance around displaying 3D files, it's not specified a format. So I think that's a bit of a mistake, but so you're pretty open to what you can use in the S1000D world for 3D files or the delivery of 3D files. So the main thing is that you have to kind of detail that within some business rules to say what you're going to deliver, but not necessarily what file format. You're not kind of mandated anything. But the caveat is with any of these publishing formats is how do you author them? How do you add that interactivity, hotspots, animations, and so forth? You're going to need some software, probably over and above a CAD system, to do that. As mentioned, VRML has been around for some time. It's pretty standard. It's open, but I don't see it being used as widely in the future. Although it is kind of, I would call it now perhaps a legacy format, although people are going to probably hate me for that, but I do see it really now as more of a legacy format because it was superseded by X3D. And finally, the GLTF, GL transmission format. This again is open. It's a light file. You can have, there's two kind of parts, I would not say versions, but parts to it. There's the GLTF and then there's a GLB, which is just another way of actually writing the file as a binary file. That's where the B comes from, which makes the file even lighter, to be honest. So not as big. So it really minimizes the size of the 3D file. And we'll probably have an example of that later on. I think that engine, our kind of marquee kind of 3D file, reduces down by nearly 2/3 or 1/3 of the size. So a quick just demo. It's not a very long demo, this, but just to give you a sneak preview. There's a site called modelviewer.dev where you can have a look at GLTF and GLB files. It's all really based around HTML, so you can see the HTML code on the left here for this particular 3D model, and it's really very, very quick to maneuver and orbit around the model and so forth. And everything is documented about this, the viewer, and also there's an editor as well, which we'll go and look at in a few minutes. But everything is on the web. It's all there for you to look at it, and all the documentation there is as well. So I'd recommend you look at that if you want to learn a bit more about GLTF and GLB. And the other one I was talking about is 3D PDF. Again, it's open. Obviously, PDF became an open format a few years ago now. But this 3D PDF is really a standard PDF file with 3D content enabled in it. So it's governed by the 3D PDF consortium. And inside the PDF, you would find the 3D file is embedded, and it would either be a U3D or a PRC file. Probably PRC is more popular. It was developed by Adobe. And the nice thing is it can be stored within the PDF, but also extracted for future use, which is quite interesting. If you need to archive a file, then you can actually bring it back out again and then probably reuse it in the future if you needed to. So before we do the poll, I'm just going to, this was one I pulled down, an example, and so we can maneuver the model, obviously in space. So this is just a PDF, and this is Adobe Reader. The interactivity works. Just a caveat on this is that this doesn't happen just kind of on the fly. You have to author this in some way by using some software. So, but we can zoom in on the model, and it kind of goes to wireframe when you're actually maneuvering it. That's just really to speed the rendering up. So my only caveat about this is just one PDF file. So if you had a manual, you'd have to stitch all these together, and I forget what the file size of this is, but I think it's around 8 megabytes or something like that. Let me just double check it, and we'll come back to the. Sorry about that. Can't get to my desktop. Okay, that refuses to go to my desktop. Let's hold on. Okay, so let's just look at the properties of that. So it's about 7.5 meg. So you begin to, if you have a multitude of these, stitching those together is going to actually, you're going to end up with a very large publication. So I can see it being used, but perhaps it might be used more in kind of service bulletins or something like that. I think to pull a whole manual together in PDF would be a challenge with all those 3D files. Okay, so oops, sorry about that. So the next poll, I'm just going to start. Just bear with me a second. Okay, so I'm going to launch this one. So this is just on the publishing formats. Just interested to see if anybody is publishing in 3D on the webinar today. So I've opened that up. It could be that none of you are, and you're all it's still in a 2D world. It could be just that you're not using any of the formats. So, but we have somebody voting. In some ways, this is good because it means that we're hopefully giving you some good information about formats that you might use in the future. So I'll give you a few more seconds. Okay. Right. Well, not everybody's voted, but I'm going to close. I'll give you another minute. Okay. Right. I'm going to close it there. Only about half of the people voted, so I'm going to share it. So as you can see, we have some people using 3D PDF, 67% other, which is interesting. I'd like to know what the other is. So nobody is using X3D, GLTF, and Vermal. Surprised nobody's using VRML. This is surprising. Okay, so I think the interesting thing is here is what is the other. So hopefully if somebody's willing to share that with us in the Q&A session, that'd be good. Okay, so I'm going to hide that. Let's quickly go back to the slides. So the other format, just to introduce you to it, is our own format that we've developed called VX3D. So why did we do this? Well, we have a software called VisX Edit 3D, and we were looking for a suitable format to actually save work that we did in the software. And we couldn't really find anything that met all our requirements, all our criteria. So what we did is we created this format. So one of the main things that was missing was we have an ability to actually convert a 3D to 2D with hidden line removal. So a lot of the open formats, certainly the publishing formats, weren't able to do that. So that's why we actually created this format. Also, the kind of benefit from that is that oops, have we lost the slides? Oh, interesting. Okay, so that is strange. Sorry about that. So yeah, the slides actually went off then. Oh, we lost the screen sharing. So apologies. So why did we develop the format? It was really for the own internal format for VisX Edit 3D. So what we're not positioning this as a publishing format. We're not positioning this as something you would use in your own business to share your files outside the company with. This is purely a format for us to save the file and then enable you to export in different formats. But the good side of that is that a step file, which is 51 megabytes, can now be saved and is 35 megabytes, and that it's literally seconds to open it. And any work that you actually do is saved. So that is a major benefit of introducing the format into VisX Edit 3D. So I think the world's got enough 3D formats, so we certainly don't need any more for data exchange. So this is purely for native use. Okay, so what I'm going to use now is VisX Edit 3D just to do some demonstrations of some of the things we've been speaking about this morning. Okay, so this is a step file. This is the engine I just spoke about, which is about 51 megabytes in size. So, but once we've got it in the software, and usually any software for that matter, once it's loaded into memory, it becomes a lot easier to handle. We can zoom in very quickly and so forth. Just be aware that we're obviously on the webinar, so you will probably have some lag on here. So what I would usually do is actually maneuver this to, in this case, the isometric view that I'm looking for. And then I might want to begin to kind of explode this file away, or some of the parts away on the file, to begin work on it. So this is where our new format comes in. So this is where I could save the file as a .vx3d file. And we'll just replace that one. So that will now be in that file will now be in that state. So it now becomes a VX3D file. Okay, it just says it did it in 11 seconds. Okay, so I've saved that to the desktop. I again can reopen that, and it's a lot quicker to open than in the original step file. But let's see if we can open it up. So it should be on the desktop. It always seems longer when you're actually doing a demo and waiting, but I think it takes about 9 seconds or something to open it. Whereas on this is obviously on my machine as well. It's actually 12 seconds. But you can see it's reopened it in that state that it was in before. Okay, so then I have the, so I can still work with this file. So let's go to step here, and I'm going to just isolate this. And I can then work with just part of the assembly, begin to explode this off as well. So, and I could save it again in this particular state. And this is where we had the difficulty is actually now, if I want to save this as a CGM, a 2D file, then a lot of the formats that we trying to use as a native format didn't support the ability to do that. So I'm just going to save this as a CGM. Okay, some of the settings are at the top. I don't want to dwell on that too much today. But certainly with the step file, the best quality we get is with converting to 2D is with that particular format, or it could be IGES for that matter. So we see more traditional type illustration from that 3D file. Okay, let's just go back to okay, but just need to go back to our original. Okay, so from here, I mentioned those other 3D formats. So if go to File again and Export, one of the options we have is going to X3D. So the thing I like about X3D is there's something called X3D DOM, which means you can actually put this straight into a HTML file. So it embeds the 3D file into it. And if we just go to that option, and we've got some kind of settings we can put up here. I'm not going to again go into those in too much level, but one of the options is to actually export the model tree itself with the 3D model. So let's just try that, and it should open it up straight away into the web browser when it's done. Again, it just takes a couple of seconds to do that, and then just opens up in the web browser. Okay, so obviously we exploded the model. We can zoom in on it, and we get the model tree on the on this side here. Now this does interact with the model. If I let me just see if I can find the spring, the fan. You can see that it highlighted the fan there. So I think this could become useful for kind of obviously, the spare parts world where you want to identify parts and so forth. So we're kind of still perfecting this export from it. You can see that there's a lot of extraneous data in the model tree, but in the next iteration of the software, we'll be able to change names on that model tree and export those, edit them out or in as we need them. So that's going to be more interesting and more useful. But as I said, this is the X3D format, and you can see that this is just in Chrome in the web browser. So we're straight into Chrome and viewing this, and the actual way that you can zoom in, and it's pretty quick how it handles the model. So that's definitely a viable format for putting stuff in the internet, I would say, from a 3D point of view. So let's just go back. So one of the other formats we mentioned was GLTF. So I'm just going to do the same model, I think. Export this out. Let's try GLTF. In fact, we can just rename this and make it a GLB file, I think. Again, I'll put this on the desktop. Okay. What I forgot to actually do here is disable the, it'll try and open it in something called the Microsoft software 3D Paint, which doesn't handle it very well. I think it's only used for small files. So a better kind of alternative really is to use let's use the model viewer. Oh, no, let's try the so what we can do is we can, excuse me for, I'm just checking you can still see this. So this is the file I created. I drag and drop it into, this is the model editor, which is part of this model viewer development. And you can see now that I've dragged that into the box here. So this is the GLB file. So this is quite a useful development tool just to see how you can handle this particular format. And what I mentioned earlier was that it's important that I think with publications that we're able to add kind of metadata to this. So everything you've seen so far, that is, you can see the HTML code snippet on this right hand side. So let me just, this is the edit button here. You can see we've got hotspots. So you can add a hotspot to this. You can add a label to it. And as we move around, when I mentioned placarding, can you see how the text does not change its orientation? I certainly know that is one of the requirements of S1000D, that the text remains flat, doesn't rotate with the model, so you wouldn't be able to read it. So we've got quite a lot of work to do on this. We're working on some kind of use cases for this. But all the HTML, because this is just HTML, is here to create this so far. So I think that's pretty impressive. Certainly the speed and so forth, and you can change the lighting in here. There's a lot more you can do than just add the hotspot. So and obviously we need to know how we're going to link those into perhaps into the text, into a parts list, or this could also. GLTF is also capable of doing animation and so forth. But this seems to be a good way of interjecting perhaps into an interactive manual 3D data into an item without the need of really of a viewer. So there's no viewer here. It's just working within Chrome again. So let's just go back again. So the other thing we did here was that we also made it possible to open back up the GLB file or the GLT file as well. So let's import that instead of open it. So this file was just an example I found on the internet, and it's again a GLTF file. again, we get the 3D, and we can work with it within here. So, it seems to be quite a good interchange format, really, as well. GLTF. We can reopen it. We can do things with it. We can explode it using our tools here. So let's just take that out. And we get the model tree as well. So very impressed by this particular format, and it's something we're going to work with going forward. Okay, so hopefully that's been useful. Obviously, it's a bit of a whistle-stop tour of publishing formats, but we certainly think there's a lot of scope here for publishing 3D data that perhaps wasn't there in the past. So obviously you might be using things already, but I think there's a lot more out there that you can take advantage of. So just in summary of the benefits of 3D, obviously I come from a world where we really created 2D illustrations, but I think finally things are beginning to move forward, and it might be because of technology, software, all sorts of reasons like AR, augmented reality, glasses, and so lots of different kind of things are coming together. But the ability to view components from any viewpoint is a nice thing to be able to do. It could be a bit of a distraction, but I think it's overall it's a good thing to be able to do. Certainly, it would help in the recognition of component parts if you can actually look at them from different angles. If you're doing procedures for disassembly or assembly, you could animate those and give somebody a very kind of good overview of a complex procedure rather than trying to write that down, step one, step two, step three. If you actually see that happening, then that's a very powerful thing to be able to do to enable the maintainer to work on a particular system. And also we come to like AR and VR, you still need 3D data to work with. So you need a format that you can use. Certainly, I know GLTF is being used in that kind of world. So, but now we can see it could also be used in, say, an IETM, an interactive manual. So I think AR and VR are becoming more popular, but you can't really use that for everything. You can't use it in a publication, perhaps. Certainly not for everything within the publication. The cost might be too high. So I think from a field service point of view, you can go to Vuzix. They create some glasses that you can use to actually project the information that you need, virtual reality. But perhaps you've just got the manual there as well, which can even contain 2D information and text still. So I think there's a lot of possibilities for kind of having a hybrid of 2D and 3D. So if you're interested in evaluating Vuzix Edit 3D, we've opened the program up to everybody. So you can email me at david.mannock@cgemlarson if you want to participate. We can just send you a link to download and a evaluation key, and you can try all those things out. You can publish those formats. You can open those formats. So I'd encourage you to, if you're interested, just to email me and we can get that out to you pretty quickly. And just in summary, I think data exchange is pretty straightforward if you're using, say, STEP, for instance, which a lot of you are. I think selecting a 3D publishing format is more not difficult, the wrong word, but certainly there's a lot to choose from, and sometimes you might be guided by what you have internally. But I think it's important that you choose something that has some longevity behind it. And certainly file size should be a consideration. Is it compatible with web browsers, preferably without a viewer, something that you would embed from a viewing point of view, because that can be troublesome. And also you need to consider what the requirements of the technical publication are. Is there hotspots? Is there interactivity? Is there in animation? Also, the fact that if you're working on a file, a 3D file, you kind of need to return to it at some point if you need to modify it in some way, and that's why we went with creating our own native format .vx3d. So you actually worked on a file, exploded it, and that there was no way of archiving it. You'd have to go back to the CAD system if you moved it out of there, or even if you've done the work in the CAD system, you might not be the only user of it, so you could actually lose that information. So just some thoughts there. And as the year progresses, we'll update our 3D strategy and also software. So just stand by for future updates on that. So at this point, I'm going to let Don join us and just have a look if there's any questions. Hi, Don.
Yes, I'm here.
Okay. The first question is have we looked into WebGL? And I thought WebGL was a basis for 3D rather than it's not really a format.
Yeah, well, it's a web API for 3D graphics, but it's an interesting question because GLTF is really relates directly to WebGL. GLTF, hence the name WebGL. GL stands for GL transmission format, and a WebGL is an API, whereas GLTF is a format for exchanging 3D graphics. So, and an interesting thing about it is that GLTF translates directly into WebGL, so it makes it a very efficient, fast language for interpreting and rendering. So it's an interesting question.
Yeah. So what would you describe WebGL as? It underpins the formats. Is that right?
It's an API. It's a JavaScript API. It's part of the HTML5 technologies for graphics in in HTML. So you have to write in JavaScript to access WebGL.
Okay. So I have another question here around S1000D, and really, I think I did say this, but I'll just reiterate. And it said, is there a particular format specified by the specification for S1000D? And the answer is there isn't one, but there is a lot of guidance if you want to go to the specification around how you display the 3D file. And in some cases, it's going to be difficult to comply to that. To be honest, I don't think you would fail anything from a delivery point of view unless it's a failure to the customer or to yourselves, to your project business rules. I think the only danger is that without a file format, then there's going to be a lot of file formats being used, and that really kind of defeats the object of S1000D in interoperability. So I would certainly encourage anybody who's choosing a format to choose an open format. That would certainly be what my preference anyway. But I think, and I don't hear anything in the future of them specifying a format either. So CGM is still the format for 2D for delivering information, and certainly SVG has become very popular more as a display format because it's native to the HTML5, and I think that should actually reflect on your choice of 3D as well, file format. That if you're going to have a way of delivering information now, it's going to be primarily probably in a web browser environment. So you really need a format that works well with the web. Okay, so another question is around JT. Will we support JT? And it's certainly on our roadmap, but it's not something we're going to implement in this first version of the software. So we feel that probably Step and certainly I just kind of fulfill most of the probably all the requirements for data exchange. Probably the advantage of JT would be for bigger file formats, or bigger pieces of equipment where the file size is going to balloon. Then JT might be more useful for that to import anyway. But certainly once we've imported the file, we can save it and it will reduce the size down. Okay. So if there's any more questions, I'd certainly be interested to know the other. If we go back to the poll when we had what people were using for file formats to publish, if anybody wants to share that with us, that would be good. Either you don't have to do it in the webinar, but in the in an email, that would be good, because it'd be interesting to see from our strategy point of view if we're focusing in the wrong direction or we need to add something to our software to support in the future. So that would be good to learn. Have you anything to add, Don?
No, that's all I had.
Okay, good. So I'd like to thank everybody for attending today. We hope you enjoyed the webinar and hopefully learned something about the formats, both data exchange and publishing. And hopefully you can join us again soon for the next webinar, which will probably be in March sometime. But in the meantime, have a good day, stay safe, and we'll speak to you again soon. Thank you.